My smart city IoT design needs to connect to the cloud. Simple, right? It's just right up there. Of course, the cloud is actually thousands of servers in a data center somewhere out in the wilderness next to some big hydroelectric dam or something. And that's connected to some big old fiber optic pipes to the internet backbone, which I don't really understand much of beyond the whole internet backbone part. But I do know that it waggles its way through a bunch of cables, maybe flies up to space and back, and then finds its way to an ISP or maybe a cellular internet provider. And then it heads down more cables, or maybe through some cell towers until it reaches some Wi Fi hub or smartphone or IoT hub of some sort. And then that thing is just so close to my IoT edge device. Maybe in the same building, or even in the next room, or even inches away. It's like the IoT is mocking me. And all I need is a wireless solution for that last leg. And I have to admit, Bluetooth and Wi Fi can be pretty confusing with all those different versions and types, and well, you get the picture. Hi, I'm Amelia Dalton, host of Chalk Talk. Today, my guest is Matt Rose from Panasonic, and we're going to talk about wirelessly bridging that last critical link of the device to cloud chain with some easy-to-use wireless connection solutions. And before we get started, don't forget to click that link. There you can find even more information about Panasonic's wireless connection solutions. Hi, Matt. Thank you so much for joining me.
Sure, my pleasure.
So, Matt, just about every IoT project I run into requires some kind of wireless connectivity. But before we dive into that, tell me about how you see the whole IoT landscape.
Well, I like to couch IoT in the smart city. And within the smart city, there's different applications. So you have the smart home, the smart building, smart manufacturing, and smart medical.
Okay, so what IoT applications and solutions are we going to be talking about today?
Well, I'd like to talk about 4 products from our portfolio. And I'd like to talk about specific applications within IoT for those parts. So we'd like to talk about the smart home and the Pan 1760A and Pan 1762. I'd like to talk about smart office building. So we'll talk a little bit about the Pan 1740 and Grid Eye. And I'd like to talk about smart industry or smart shop floor. So we'll talk a little bit about our Pan 9420 Wi-Fi module. And then for smart hospital or smart medical, we'll talk a little bit about our Pan 9026.
Now, when you think of a typical IoT application, how do you break it down?
So when customers talk about the IoT, I like to clarify what we're really talking about. And so the 4 components of IoT consists of the node, the gateway, the network layer, and the application layer. Now at Panasonic, our products are focused on the node.
Okay, let's dive into the wireless connectivity part of that. Now, if I want to add wireless to my application, what do I need to know about the various protocols?
When I'm talking to new customers who want to add wireless to their products, there's 6 factors that I discuss with them. First is what's the range of their application? What is the DC power situation? Are they running off a battery or is it plugged into an AC outlet? What data rates are they after? Is it a low data rate type of application where they're just passing some state information? Or is it a higher data rate application where they're wanting to do file transfer? The other 3 factors are form factor, the network topology. Is it a star network? Is it point-to-point? Is it a mesh network? And obviously, price is always a consideration.
So we're going to be talking about Panasonic modules as we go through this. But first, can you give me a brief overview of what a module is and why I want one?
Well, a module consists of a supplier's plastic packaged part, the die, and then there's maybe crystals, different RC components. So Panasonic takes these components, they do RF layout, they do quality testing, reliability testing, so that for the customer, it's just a plug and play proposition. We provide software from the supplier, and our FAEs and support engineers help the customer bring the product to market. And so it's one less thing that they have to worry about from a production standpoint and from a cost and headache standpoint.
Okay, let's walk through some of the application areas you mentioned earlier. How about we start with smart home?
Yeah, so let's talk a little bit about where we're seeing IoT and wireless in the home. So, different applications that we're seeing in the home with wireless is security is very important, notifications, so say like a doorbell type of application, temperature monitoring, thermostats. So, it's very exciting what we're seeing in the home.
Now, I've always been a little confused about this, but there are a lot of different flavors of Bluetooth, right?
So that's correct. So Bluetooth is governed by the Bluetooth Special Interest Group, the Bluetooth SIG, and they introduced Bluetooth in 1997. And so when we discuss classic Bluetooth, that's versions 1 to 3, and the applications for that typically are file transfer, or some folks want to use classic Bluetooth to communicate with their PCs. Then in 2010, the SIG came out with Bluetooth Low Energy. It's what we call BLE or Bluetooth Smart. So the takeaway here is that you have Bluetooth 4, 4.1, 4.2, and now 5.0. So the state of the industry now is Bluetooth 4.2, and we're starting to see suppliers with Bluetooth 5.0. And we'll talk a little bit about the differences between 4.2 and 5.0 here in a bit.
Okay, let's dive into some Bluetooth details here. How does it look under the hood?
Sure. So there are really two different modes to pass information in Bluetooth Low Energy. There's the advertising mode and the connected mode. So typically you can pass 20 bytes of information in 4.2 in the advertising mode. So I can have a thermometer up on the wall passing the temperature on a regular basis to anybody who wants to listen. In a connected mode, I can pass information on a regular basis or whenever the information is needed from the central unit.
Okay, and I know Bluetooth is passing all of this information through RF connections. Now, how does Bluetooth use the spectrum that's available?
So in Bluetooth Low Energy, like I mentioned, there's an advertising channel and a connected channel. So you get 3 advertising channels. They're channel 37, channel 38, and channel 39. And then the other 37 channels are used in the connected mode. And notice in red, the popular Wi-Fi channels 1, 6, and 11. So the advertising channels are actually spaced around those so as to not interfere with the advertising.
So you mentioned something earlier about the different roles. Can you explain those to me, and how exactly do these work?
So in Bluetooth Low Energy, there are 2 roles. There's the central role and then the peripheral role. So the central role is an item that's plugged into the wall or is like your phone that has a good sized battery. So the peripheral is an item that's usually power constrained and wants to use the battery very efficiently. And so within the central or peripheral, there can be a client or a server. And typically the server passes data to the client. So in this example, could be the XYZ coordinates from a sensor or temperature. And then there might be an application where a central device is passing time from its server to its client.
Got it. Okay, and then how is the data organized to support that?
So Bluetooth uses this idea of profiles to organize its data. And within a profile, you might have services or characteristics. And within characteristics, you have attributes. And so that's how data is organized.
Okay, so Matt, we've gone into some detail on the protocol, but what's the easiest, simplest way for me to implement BLE?
So the simplest way to implement BLE and to get your application up and running very quickly is this idea of the serial port profile. So Wi-Fi and classic Bluetooth are in essence cable replacement technologies. The idea was in classic Bluetooth to have this serial port profile to pass information from one node to the other. So this was very popular with customers. So many suppliers came up with serial port profile over BLE. So this is the easiest way to pass data from one node to another node.
So I just think of this as plugging into a port and it becomes my virtual wireless cable?
That's the essence of the SPP over BLE.
Can you give me some details about this first module?
So the Pan 1670A has very competitive power consumption numbers and also has a AT command mode. So many customers find the AT command mode to be very appealing.
And you said we have a demo of BLE in a smartphone application?
We do indeed. So this is the Doorbell Demo. So in the Doorbell Demo, we use the SPP over BLE mode. So we pass information from the central node to the peripheral node. So when I plug my modules in, the LEDs turn on, and that means that they've made a connection between the two of them. On my central node, I have a switch and the LED there, along with the Pan 1760A module. And then on my peripheral node, representing the battery-powered low power side of the network, we have the LED and a buzzer, or a little speaker, along with the 1760A. And when we power these two modules, the LEDs come up to show that they've made a connection.
So they are now talking to each other.
They are in communication, yes. And so on the central side, I'm going to press the switch, and that's going to notify the peripheral side through this SPP over BLE that the letter R has been sent. And when the peripheral receives the letter R, it'll tell the speaker to begin playing its little tune. And that is a very simple application showing the Pan 1760A using the SPP over BLE functionality.
Now, you said that was done with BLE 4.2. Now, I've been hearing a lot about BLE 5.0 lately. What's up with that?
So there are three new features that most customers are interested in with regards to 5.0. The first is the 2 megabit PHY, so there's an increased bandwidth. There's a coded PHY, which provides longer range, and there are some advertising capabilities that some folks might find interesting.
And in my application, my big issues seem to be range and throughput. How's that going to be in 5.0?
So in 5.0, you can either get higher speed throughput or you can get longer range. So in 4.2, you have the standard 1 megabit per second air data rate, and you can use that in 5.0, or you have the option of increasing that to 2 megabits per second, or you have the option of using a long range mode, the coded PHY mode, at 1 megabit per second. And they have these factors S equals 2 and S equals 8. And so your effective data throughput at the S equal 2 mode is around 380 kilobits per second. And then at the longer range mode, at 125 kilobits per second, you have an effective data rate of 109 kilobits per second. In order to facilitate these longer ranges, the Bluetooth 5 uses forward error correction. And so that gets you this longer range mode.
Got it. And that extra range and bandwidth are going to be really helpful for me. Now, tell me what device we're going to have that supports BLE 5.0.
So we've just come out with a Toshiba-based device, the Pan 1762, which is our 5.0 device. It will have the AT command mode. We're also anticipating the SPP over BLE mode, and it will have very competitive power numbers as well.
All right, let's move on to your next application area, smart buildings, right?
Right. So another common application that I come across is smart building. And, whether that's lighting control, air quality, energy management, also occupancy management. So one interesting application that we have is using our Pan 1740 BLE module along with our Grid Eye. Now the Pan 1740 is a very small size and also has very low current consumption. And we've coupled that with our Grid Eye infrared image sensor. And we have a dev kit that shows this application in use. Now, the Grid Eye consists of a lens, a microprocessor, the IR detector in this ceramic package. It's an 8x8 pixel infrared detector. And in this application, we can see the two folks walking through the field of the infrared sensor, and we could pass this information by way of Bluetooth Low Energy to a cell phone. And so a manager in a department store could use this in an application to monitor a dressing room at closing time, and to see if there was anybody in the dressing room, or it can be used in occupancy detection in order to minimize energy usage in a conference room setting.
Okay, cool. That's a kind of development kit and reference design that I could use as my starting point for my application. And your next use case was smart manufacturing, right?
Right. So we're seeing many IoT applications in manufacturing, and one example is the smart shop floor. Now, a little bit about the background of Wi-Fi. I'm not going to go too much into the detail, but the things to know are standard state-of-the-art now is ABGN Wi-Fi. So you can 1 megabit to 5 megabits per second typically in that. We're also seeing AC solutions, and this year we're going to start to see AX solutions. Now, I'm not going to get into AX too much, but that will be the state-of-the-art this year.
So we've switched gears to Wi-Fi. Now, give me an example of what we can do with Wi-Fi.
So using our plug-and-play Pan 9420 module with one of our Panasonic PIR sensors, we've created an application to monitor packages as items go down a conveyor belt.
Great. I love anything with conveyor belts. So tell me more about the Panasonic solution that was used in that.
So this is based on our plug-and-play Pan 9420. This module can attach to the customer's access point through station mode, or it can be an access point itself. So I can have my cell phone or my tablet attached to the module and stream data from the internet through the module. It also has a web server to house applications on the module itself.
So please tell me we have that conveyor belt demo.
We do indeed have a conveyor belt demo. This is the infrared sensor attached to the Pan 9420. We power up the Pan 9020 and we go to GPIO 4, take a look at GPIO 4. So then as the box goes through the PIR sensor, we see the GPIO 4 transition from off to on.
I don't see any conveyor belts.
Well, you'll have to imagine a conveyor belt for this demo.
That's just not as fun.
Well, it's engineering.
Okay, now that I'm getting sick of this smart factory, let's move into the smart medical or smart hospital.
So with regards to smart medical, we're starting to see a lot of IoT technology in hospitals and medical applications. So typical application is patient monitoring. And we have our Pan 9026, which is a Wi-Fi, classic Bluetooth, and BLE combo module, which is great for medical applications. And it requires a powerful Linux environment, so an IMX6 type of processor, and provides Wi-Fi, classic Bluetooth, and BLE 5.0 functionality. Uses an SDIO interface and has a temperature range from -30 to 85 C, so it's very good for patient monitoring type of applications.
So why would I want to use one of these versus the previous solutions you've showed me?
So in a medical environment, having Wi-Fi, classic Bluetooth, and BLE in one application is very appealing. So you can use Wi-Fi for the back-end data transfer to the hospital's access point. So you can use classic Bluetooth for audio streams so a nurse could converse with a patient or to have a microphone. Many applications for BLE for command and control in a medical application to have sensors to monitor a patient's health, temperature, what have you. And then also use BLE for beaconing to track patients in a medical environment.
Okay, and tell me what kind of development kit you've got for the 9026.
For the 9026, we use the WAN board from NXP, and that's based on an IMX processor. And then we provide a demonstration code based on Ubuntu Linux. And our support engineers can walk you through the process of Linux development.
Okay, I think I'm ready to go make smart everythings. How do I get started?
Well, so we mentioned the dev kits before. We also have a new dev kit platform called the IoT Workbench that will be coming out this year. And Panasonic offers production programming, so we can help you program your software, custom firmware on your devices as they're shipped to you. We also have our RF module support forum, which is forum.na.industrial.panasonic.com. So we have our FAE team here in North America to also provide support, as well as our regional sales managers. And then we have our online support forum.
Okay, Matt, so give me a recap on why I want to choose a Panasonic solution here.
So our value proposition is that we have products that are technically competitive with the market. We have our relationship and support, so actual people that you can talk to in case you come across challenges, and then our quality and availability. Panasonic prides itself on its reliability and quality of its products, so we perform a full suite of reliability tests on our products, and also our products have long lifetimes. So we support our products for many, many years, and we also try to maintain pin-to-pin compatibility within our product families. And price is also a very important consideration.
Okay, great. Well, I'm going to click that link and go to a Mouser.com page for more information. But before I do, thank you so much for joining me, Matt. It was a pleasure speaking with you.
Thank you, Millie. It's been my pleasure to be here.
And before we go, you didn't forget to click that link, did you? There you can find even more information about wireless connection solutions from Panasonic. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. Can't miss it, right across the top. Or head on over to YouTube. Keyword EE Journal.